Hi everyone, in this video I want to start talking about solving exponential and log equations. So the basic tools that I want you to keep in mind as we're doing this are just like you could square both sides of an equation or square root both sides of an equation or add 5 to both sides of an equation, you can also take the log of both sides of the equation or exponentiate both sides of the equation. Meaning if you have a something equals something type statement, you could raise both sides up and put them in the exponent as long as you're using the same base on both sides. And you could also take the log of each thing and expect them to still be equal to each other as long as you're using the same base on both sides. Here we do have to be a little careful. X could equal y, but if they're 0 or negative, this is not a legal statement to make. So if we're going to introduce logs, we want x and y to be non-negative numbers. What else? If we eliminate logs from an equation, having a log in an equation introduces some domain restrictions. So getting rid of them, we lose track of some of those domain restrictions, and we might possibly introduce an extraneous solution. So anytime we're solving an equation that starts off with logs in it, we always want to check for extraneous solutions. Even if we are 100% sure we did not make a mistake, we could have a bad solution. Okay, so I'm just going to start working my way through some that aren't very messy and see if we can figure out the tricks that we need. But again, basically that's it. If you need to eliminate logs from an equation, you should exponentiate. If you need to eliminate exponential pieces of an equation, you should take the log of both sides. Do be really clear that the entire left and right hand sides have to go up into the exponent with a single base b if you exponentiate. And same thing with logs, the entire left and right hand side have to go inside the two logs. You can't split that up into several logs. So be really strict with yourself on actually doing the step where you exponentiate or take the log. Okay, first pair. Again, we're going to start off with things that hopefully aren't too messy and see if we can be really careful and figure out all the tricks along the way. So here, if I'm trying to solve for x, I'm hoping to get rid of this log because there's no base. I'm assuming that's a common log, log base 10. To get rid of a log base 10, I would need to use an exponential with a base of 10. So this is going to be an exponentiate step. If these two things are really equal to each other, then 10 to the log of x should really equal 10 to the negative 3. And the 10 to the log of x, that's composition of inverses, so those two should wipe each other out. If I take the log base 10 of something and then raise that to the 10, I should just get my something back. The 10 to the negative 3 is 1/1000th, and there's my answer. I do want to check. This is a not optional check. My pen's dying. Let's see if I have my green one handy still somewhere. I do. Okay, so we need to check and make sure that we don't violate any domain restrictions in the original problem. So if we plug 1/1000th in, it is completely legal to take the log. So I don't have any domain problems, so it's not extraneous. If you want to check a little bit more thoroughly, you can actually ask yourself 10 to what power gives you 1/1000th and see hopefully that it is in fact negative 3. So not only is that not an extraneous solution, it also appears to be a good solution, the correct solution. Okay, so to get rid of logs, exponentiate. In this next one, it's a little tricky because the bases actually are unknown. So if I want to exponentiate to get rid of a log base x, I will have to use a base x. X to the log base x of 81 should just give me 81. So I'm working on 81 equals x to the 4th. So interestingly, because here the variable was actually the base, this turned this into a 4th degree equation. I now want to get rid of a 4th power. We do need to be a little careful. There are two things that we can raise to the 4th to get 81. So basically we want the 4th root of 81, which is 3, but we should get a positive or negative 3 for our x. So if you're introducing an even root, you need a plus or minus on that. let's see, what else do we want to say here? We are looking at, so we do need to check here, but this is actually kind of a different check. It's not a domain thing. When we talk about the domain of a log, we're talking about what we plug in as our input. This is a base thing. So the rules are very slightly different. The input of a log has to be positive. The base of a log has to be positive and should not equal 1. We don't have 1 here, so that doesn't end up mattering very much, but we do have a negative possibility. So in the end, we're just going to say x equals 3 is our only solution.